Good morning, everyone. Yes, it's Dom. Right, okay. I hope you're all safe and well, looking after yourselves, being good, doing all your work. Now, what I wanted to do was just quickly go through with you weak acids. Hopefully, you've had a look at Moodle and the PowerPoints that are on there for you to access. So we'll make a start anyway. If we think about a weak acid, so good example, ethanoic acid, what you find in your vinegar, okay? Ethanoic acid CH3COOH. This doesn't completely disassociate to release all of the protons, okay? And protons are what give rise to acidity, okay? Because if you remember, again, looking through those PowerPoints, you will know that pH equals minus log to the base 10 of the hydrogen ion concentration. And I'll be coming back to that in a minute. But if we go back to ethanoic acid, the way we would want to write how it disassociates, so we put a little reversible reaction arrow in there, and that produces CH3COO minus, so a negatively charged base, plus our hydrogen ion. Okay, and we always refer to these, so the acid would be HA, the base, A minus, and of course the hydrogen ion would still be hydrogen ion H plus. Now, one of the things that you can calculate with weak acids is something known as the dissociation constant, which is Ka. Okay, Ka equals concentration of A minus multiplied by the concentration of H plus divided by the concentration of the acid. Now, when it comes to finding out the concentrations, we could know the concentration of the acid anyway, but we tend to not know what the concentration of A minus would be. But we do know through measuring pH, we can calculate what the hydrogen ion concentration would be. And because of how it dissociates, so how many hydrogen ions are liberated, you will always get the same amount of the negatively charged base as well. And because of that, we can simplify this equation further, and we can say that Ka equals hydrogen ion concentration squared divided by the concentration of the acid. Okay? And let me give you a worked example of that so that it can just bed in a little bit better. So sticking with ethanoic acid, so a concentration, remembering we always write concentration in square brackets. I'll give you a concentration of ethanoic acid being 0.25, and the pH is 2.69. Now, of course, if we need to know what is Ka. Yeah, Ka question mark. Don't know what it is. Looking back at the equation, we need to know hydrogen ion concentration and also the concentration of the acid. We've got the concentration of the acid. We've got a pH. Now, as I mentioned earlier, pH equals minus log to the base 10 of the hydrogen ion concentration. If we need to know what the hydrogen ion concentration, so therefore our hydrogen ion concentration is the inverse of the log to the base 10 of the minus pH. Okay, so I've got my trusty calculator here, okay, very similar to the ones that you've got. So we're going to have a go at this. So I gave the pH being 2.69, so I click shift log minus 2.69 equals, and there you can see 2.0417 times 10 to the minus 3. Okay, so we know then that our hydrogen ion concentration equals 2.0417 times 10 to the minus 3. And of course our equation asks for that to be squared. So we can write Ka equals 2.0417 times 10 to the minus 3. We're going to square all of that. Remember, when you come to square it, use the whole number that's given on your calculator. Easy way of doing that, whilst the answer's still on there, press the x squared button. Okay, equals that, so it's 4.168 blah 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 times 10 to the minus 6. So it's that divided by, and it's given us the concentration 0.25. So whilst that's still in the calculator, divide that by 0.25 equals 1.667 times 10 to the minus 5. And if I rounded that up to 3 significant figures, okay, that's going to equal 1.67 times 10 to the minus 5. Okay, take you a little bit to digest that, but look through what I've done. Okay, have a go yourself with that information. Check that you know how to use your calculator, how to use these different functions. Okay, and hopefully you shouldn't be too bad with that. Okay, I'm going to be producing another of these little videos to help you with amino acids. Okay, so that will be also included on Moodle. I'll also email these out anyway. You'll see that. Good luck everyone, and don't forget, if you've got any problems, send me an email, and of course you can always have a look on ChemGuide. Fantastic resource that goes along with Unit 16. Okay, good luck everyone, and I'll speak to you again when I get on to amino acids. Take care.